Welcome to yet another session in Computer Fundamentals. In this session, I'm going to demonstrate to you how to perform the subtraction using 1's and 2's complement. I'm going to solve few of the problems that are listed in the Unit 3 of your question bank. Let us try to perform the 1's complement. I'm going to take the first problem over here, and then I'm going to perform the 1's complement. So to do that, I'm going to start my PowerPoint. Let us first learn what are the rules for performing 1's complement. To obtain the 1's complement, we are supposed to get the 1's complement of the subtracting. So from the given problems, select the subtractant and then find the 1's complement. Add that to the minute and observe the carry. If there is a end around carry, add it to the least significant bit of the result. If there is no end around carry, take the 1's complement of the result and then put a minus sign before it. I know it sounds like French when I read the statement which are written here, but when you try to solve the problem, you find that these steps are very easy. So let's start with the first question, and this question I am taking it from your question bank here. So the question 2 of this, so I have copied it over here. This is what we are supposed to do. I am supposed to subtract 1001 from 1011. Now there are two words that were mentioned there. One is the minute and the other one is the subtractant. The first one is called as the minute. So this one is called as minute. The second one is called as a subtractant. So that is simple as that. Okay, so that is as far as the mathematics. I have nothing to say about it. But before you perform anything, first thing, ensure that both of them have the same number of bits. So what do I mean by saying that is write the minute first and then write the subtractant below it and check whether there are equal number of bits are there in both of them. So you must get the equal number of bits. If there are less number of bits in the subtractant, then put additional 0 here. If there is, in this case they are equal, so you have 4 bits in the minute. So if you look at here, there are 4 bits are there, 1 2 3 4, and in the subtractant also there are 4 bits are there. So if there are less number of bits, go to the subtractant and make additional, put extra 0 on the left hand side so that the bits are equal. If you don't do that, you will get a wrong answer. Now, as far as the steps, we are supposed to perform the first step. What does the first step say? The first step says that take the subtractant, that is this one, subtractant, and then perform the 1's complement. So take this subtractant and perform the 1's complement. How do you perform 1's complement? To perform 1's complement, the steps are very simple. Wherever there is 1, you put 0. So that is simple as that. So if you have a 1 here, make it as 0. If you have 1 here, make it as 0. If there are 0, make it as 1. If there is 1, make it as 0. This is called as inversion. Invert the bits. So wherever 0 is there, put 1. Wherever 1 is there, put 0 at the same place. So this is called as 1's complement. What is important over here is some of the students don't write this step during the examination. You are supposed to write this step. Even though you find that this is too silly, but you are supposed to write this step to tell the examiner that you have found the proper 1's complement. If you don't write this step, you may lose some marks, even though you go to the next step very quickly because you feel that you know it. Write that this is the 1's complement of the subtracting. Now, as far as the steps involved, we are supposed to take the minute, and that is this one, minute, and then take the 1's complement subtractant. Now, even though the question here says that you are supposed to perform the subtraction, but we don't perform the subtraction, instead we perform the addition. That's very important. Some students do all these things and they simply start subtracting it. It is not the subtraction. Even though the question says it is subtraction, it is actually the addition. Okay, so you are performing the addition. So take the minute, take the subtractant, that is the 1's complemented subtractant, and then start adding them. So 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. Now observe, do you get an extra carry? That means, do you get an extra bit when you add 4 bits altogether? So there are 4 bits are there. Do you get a carry, extra digit? If you don't get, you are luckiest one. So you don't get any end around carry. In that case, take this result and take the 1's complement of the result. So take this result over here and take the 1's complement. So wherever 1 is there, put 0. Wherever 0 is there, put 1. Wherever 1 is there, put 0. Wherever 1 is there, put 0. That is not the end of it. Then put a minus sign before it, because this result is a negative result. Even though we don't have notion of putting notion of putting negative sign in binary digit, actually one of the bit is reserved for sign bit, that is called a sign bit, but we in the examination show it as minus sign, saying that this is a negative number. Now, is this answer correct or not? That's very important, because this question, if you look at this particular question, this question carries 4 marks. So you can spend slightly longer time in ensuring that whatever you have done is actually the correct answer. So how do you do that thing? Manually perform the subtraction and see whether after performing the subtraction, the binary subtraction, do you get the same result. So I'm going to show that thing. So I have not this one, I don't know why this particular thing did change up, so just ignore this part. Okay, ignore this part. I have taken both the results here, 100 and 1011. So I have this one. Okay, I think this is a copy paste error, so ignore this part. So I've taken 1001 and 1011. Then you know very well. So if you want to convert it into decimal, even though I have converted into decimal, there is no need for you to do that thing, but for the explanation I am just converting it into decimal. So this is 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. So 2 to the power 3 is 8, 2 to the power 2 is 4, 2 to the power 1 is 2 and 2 to the power 0 is 1. So just find out what is it. So this 1001, it is 8 plus 1, which is 9, and 1011 is 8 plus 2, 10, 10 plus 1 is 11. So you are actually subtracting 11 from 9. You know very well, if you subtract 11 from 9, you must get a negative number, because the first number is the smaller number. So when you subtract it, you know very well the answer is minus 2. Are you getting this minus 2? Let us do the binary subtraction. So you know very well, you cannot subtract like this. It is not possible, because you know very well this number is smaller, you can't do it. So what you have to do is, even though I have written it like this, you are supposed to perform the subtraction in the reverse order. So 1 minus 1 is 0. 1 minus 0, even though I have written it like this, subtraction should be in the other way around. This is the larger number, so subtract it in the other way around. 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0. So what you are left is 1 0. What is 1 0? 1 0 is 2 to the power 2, which 2 to the power 1, which is 2. So you are getting this answer. Is this the same answer? You are getting it in the previous situation. So if you notice, this is 1 0, you are getting it using 1's complement method, and using binary also you are getting the same answer. Let's go to the second question. I will take the second question directly from your question bank, and that is, this is the question 1011 and 1001. So 1011 and 1001. So what is the step? First step, very important step. Always student forget this one. Write them one below the other. You are, even though you say that is too silly, write it. Now in this case, when you start writing it, you will realize that both of them don't have equal number of bits. So you find that there is one bit that is missing. Put 0 for that. So that is important. If you don't do it, you get a wrong answer. So put 1, because one bit is short. Here you put that one bit. Now you have both of them in proper order. Now as far as the steps, first perform the 1's complement of the subtractant. Remember, this is your subtractant now. Take this one and take the 1's complement. How do you take the 1's complement? Wherever there is 1, put 0. Wherever 0, put 1. Wherever 0, put 1. Wherever 1 is there, put 0, and wherever 0 is there, put 1. You have to write this step in the examination and say that that is 1's complement. Now the next step. What does the next step says? The next step says that take the minute, and this is the original minute that you have, and take the 1's complement that you have taken, add them. Very important, add them. You are not subtracting it, adding. So add them, and when you add them, what you notice is 1 plus 0 is 1, 1 plus 1 is 1 0. You carry this 1 to the next location. So again 1 plus 1 is, you notice that it is, you have carried 1 over here. 1 plus 1 is 1 0. So carry this 1 again to the next. 1 plus 0 is 1. 1 plus 1 is 1 0. So you notice, when you do this, you notice that this is 1 0. Okay, so 1 plus 1 is 1 0. This one you are carrying it. Okay, so this is an extra bit. Why this is an extra bit? In the question, how many bits were given? So you were given 1, 2, 3, 4, 5 bits were given. In the answer, how many bits are there? In the answer, 1, 2, 3, 4, 5, 6 are there. That means one extra bit. You get an end around carry. So you got this end around carry. What are you supposed to do with this end around carry? This extra bit, you have to take it and add it to the least significant bit. So this is called as the least significant bit, and this is called as the highest significant or most significant bit. So take this one, this bit, and add it. In the examination, what I have noticed is some student actually take this bit and they retain this one here. This is wrong. Remember, you are taking it from here and then putting it over other side. That means it is gone from here. Don't retain it there. You are not getting one from anywhere. You are taking that one most significant bit 1 and carrying it over to here. So that means this will vanish. You are taking it from here and putting it on the other side. So once you have done that, add them. So 1 plus 1 is 1 0. Okay, I take this 1 here. So 1 plus 1 is 1 plus 0 is 1, then 0, 1, 1. So this is your answer. It is a positive answer, so you don't need to do anything with this. Let's go to the next slide and verify whether we have done it properly. So I am going to perform a direct binary subtraction to see whether we are getting the same answer. So I have both the numbers over here, so 100 and 1011. Let us perform the subtraction. So I write like this. So what is the binary, the decimal equivalent of this? So this is 16 plus 2, that is 18, plus 1, this is going to get 19. So next one is 8 plus 1, that is 9. 19 minus 9, you must get 10. So are we getting that 10? Let's perform that one. So 1 minus 1 is 0. Remember, this is the larger number, this is a smaller number, so you are always subtracting smaller number from the larger one. So this time the subtraction is directly the same way. In the last case I had the smaller number and then the larger number, so I have to do the reverse subtraction. Now this is the direct subtraction. So you get 1 minus 1 0, 1 minus 0 is 1, 0 minus 0 is 0, and you have 0 minus 1 not possible, carry 1 here, so this becomes 1 0. So what is 1 0? So again I have already told you, but just 1 plus 1, binary 1 plus 1 is 1 0. From 1 0, if you subtract 1, then you will be left with 1. So from 1 0, if you subtract 1, then you are left with 1. So what answer you are getting is 1 0 1 0. What is 1 0 1 0? 1 is 8 and this one is 2. So 8 plus 2 is 10. This is the answer. Are you getting the same answer? Let's go back and find out. Am I getting the same answer? You notice that I am getting the same answer. This 0 has no significance, so it is 1 0 1 0. Okay, let's perform the binary the ones complement subtraction on the next digit that is given in your question bank. So I have 1 0 1 1 0 minus 1 1 0 1. Now first thing, write them one below the other to ensure that same number of bits are there in both of them. So in this case same number of bits are there, so you are luckiest one. Next thing, take the subtractant and take the ones complement of it. Taking ones complement is very easy. Wherever there is 1, put 0, wherever 0, put 1, and wherever 1 is there, put 0, 1 is there, put 0, 1 is there, put 0. Done. Now take the minute which is given in the question. So take this minute, write as it is, take the ones complement, write it, add them together. So that's very important. Add them, you're not subtracting it. So when you add it, what you get? 0 plus 0 is 0, 1 plus 1 is 1 0, carry this 1 here. So 1 plus 1 is again 1 0, put that 0 here and carry this 1 to the next location. 1 plus 0 is 1, 1 plus 0 is 1. So this is what you get, 1 1 0 0. What you notice here, there is no extra carry. So how many bits were there? 1 2 3 4 5 were there. In the result 1 2 3 4 5 are there. So there is no extra carry. In that case, what are you going to do? If there is no end around carry, obtain the ones complement of the result. So take this one, take the ones complement. So wherever 0 is there, put 1, wherever 0 is there, put 1, wherever 0 is there, put 1, and wherever 1 is there, put 0. You are inverting it. So it is 0 1 1. That's not the end of it. Put a minus sign before it. It's going to be a negative result. Let's look at this. Let's verify this using direct binary subtraction. So I have both the numbers here, 1 0 1 1 and 1 1 1 0 0. Let's first get the decimal equivalent of this. This is 16 plus 4 plus 2, that is going to be 22. Okay, that's going to be 22, Again you have 16 plus 8 plus 4, that is 28, plus 1 is 29, this is 29, so 29, so you have 22 minus 29 minus 20, so you have 29, this is a larger number, minus 22, you must get the 7, because you are doing it the other way around, it is minus 7. The result is negative because the second number is larger. Now when you have the second number is larger, subtraction should be done in the reverse order. So this is a smaller number, this is the larger number. So subtract them. 1 minus 0 is 1. 0 minus 1, it's not possible, so carry 1 to this one. So what you have is 1 here, this place you have 0. 1 0 minus 1, again 1 plus 1 is 1 0. Okay, 1 0 minus 1 is 1 here. Okay, here it is 0, carry this one to here, this is 1 0. 1 0 minus 1 is again 1, this is 0 here, 0 minus 0 is 0, 1 minus 1 is 0. So this is what you are going to get. What is this one? So what is this one? This is 4, this one is 2, this one is 1. So altogether what you get is 4 plus 2 plus 1, that is 7. So even though it is I have written as 12, this is going to be 22 minus 29. Again the answer will be same because it is the only 10 extra is there on both the sides. So this is minus 7. So your result is 1 1 1 with the negative 0 1 1 1 1. So are we getting the same result? If I go back, you notice that this is the result I got it. Even if you have you can ignore these zeros. So what you have is 1 1 1, that is minus 7. Minus is also there, 7. So this is what you get. Let's go to the next one, and in the next one, this is the I think last question that was given in your question bank. In this case we have even fractions. So how do we perform the subtraction when there are fractions are there? So let's try to perform them. So first thing, very important thing, write them one below the other. Put the decimal point proper location. This is the decimal location. Write them properly. This is very critical thing during the examination. If there are less number of bits, put 0 on the left hand side, and you know where after this decimal put 0. This is really very critical in the examination. If you forget this one, you get a wrong answer altogether. So pad them with the 0 so that they become equal. So both the bits are equal. If you don't do that, you get a wrong answer altogether. So even though this is what is given 101 1.001 and 110.10, there are one bit less here, one bit less here. So I have padded it with 0. After dot you can put 0 here, it won't change the value. Before the dot here you can put 0 on the left hand side, it won't change the number. Now as far as the steps, let's perform the steps. Number 1, that is 1's complement of the subtractant. Take this is the subtractant now, this is your subtractant. Take the 1's complement. Wherever there is a, ignore this dot altogether, just perform the 1's complement. Wherever 0 is there, perform 1. Wherever 0, make it as 1. Wherever 1, make it as 0. Wherever 0, 1, and this is also 0, this is 0, and this is 1. This is the 1's complement of whatever you have got. Put the decimal point at the proper location. Now the step number 2, add them together. So take the minute, take the 1's complement, add them together. So when you add them, what is the answer are you going to get? So when you add them, 1 plus 1 is 1 0. Okay, put the 0 here, carry 1 to the other side. 1 plus 1 is again 1 0, put the 0 here, carry this 1. So let me show it properly. So 1 plus 1 is 1 0. So put the 0 here, take the carry. 1 plus 1 is again 1 0, put the 0 here, take the 1, carry here. 1 plus 1 is 1. That is done. Put the dot as it is. Add 1 plus 1 is 0, that is 1 0 again. Put the 0 here, carry 1 here. 1 plus 1 is 1 0 again. Put the 0 here, carry to the next location, that is carry this 1 to the next location. 1 plus 0 is 0. 1 plus 0 is 1. And last one, 1 plus 1 is 1 0. Okay, so put the 0 here and then 1. What you notice here, there is an end round carry. When you add it, you get end round carry. What is the meaning of that? How many bits are given here? 1 2 3 4 5 6 7. How many bits do you get in the result? 1 2 3 4 5 6 7 and 8. So this one is extra here, that is the end round carry. So this is not the 2's complement, it is the 1's complement. Okay, so you have this here. Now take this carry and then add the 1 here. Okay, this carry. So when you take this carry from here, it vanishes from here and it's going to come to the other side. Some student will retain this 1 here. Don't do that thing. Take it from here and you are putting it there. So it is not you are adding 1, you are actually taking this bit and then pushing it on to the other side. So put it 1, what you get is add them. 0 plus 1 is 1, remaining bits will be the same. Are we getting this same result? So let's go and let's perform the actual binary subtraction. So I'm going to write this bit as it is and this bit as it is. So you know very well, after dot, this is 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, and 2 to the power minus 1 is 1 by 2. 1 by 2 is half. Half is nothing but 0.5. 2 to the power 1 by 2 square. This is 2 to the power minus 2 is 1 over 2 to the power 2. This is equivalent to 1 by 4. 1 by 4 is quarter. What is quarter? 25. Okay, so you know 25 paisa. In 1 rupees you have 25 paisa, that is quarter. Now you get 2 to the power minus 3 is nothing but 2 to the power 3. So what is 2 to the power 3 is 2 to the power 1 over 8. What is 1 over 8? What is the meaning of this one? This is half is 0.5, then half of it again is 1 by 4, again half of it is 1 over 8. So what is half of 25? What is half of 25? Half of 25 is 12 point, so it is 12.5. okay, you know where 12.5 into 12.5 is 25. So that is what I have written. I have just shifted because you started with this 0. So I written is as 1.125 because it is, you are starting with the decimal here itself. Okay, so this is actually 50%, 25%, 12.5% if you are doing it. So it is very easy to remember, 125. Now let's perform the actual calculation. This is 8. This bit, wherever there is 1 bit is there, take the corresponding value. This is just a minute. This is 8 plus 2, that is 10. 10 plus 1 is 11. What about here? This is 0.125. So this is 11.125. You got it. Let's go to the next one. So next this part, I have written it here. So 4 plus 2 is 6. 6 plus 0.5. So 6.5. Let us subtract it and then see what answer are we getting it. So you subtract it 5, 2, carry 1 to the other side. 11 minus 5 is 6, 10 minus 6 is 4. 4.625 is this the answer? Are you getting it? So subtract it, this assume it as 0. 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 1 you can't do it, so take 1 from here, so this becomes 1 0, 1 0 minus 1, so again you know very well, 1 plus 1 is 1 0, 1 0 minus 1 will be 1 itself, so 1 0 minus 1 is 1. You have taken 1 from here, you are left with 0, 0 minus 0 is 0, 1 minus 1 is 0, again carry 1 to the other side, 1 minus, that is 1 0, 1 0 minus 1 is 1. So this is what you are going to get, 100.101. Is this same as 4.625? So this is 4, you notice this is 4, and then 0.5 plus 0.125. So what you are going to get, 0.5 plus 125. So what you get, 0.625. This is the answer. Are we getting the same answer? So let me go back to the PowerPoint here, and am I getting the same answer? You notice that this is the answer. I am getting it. So this is 100.101, and this is the same answer you are getting here also, 100.101. So the same answer. That's all in this video. I'm going to give you the next video in which I'm going to perform the 2's complement. Thank you for viewing this video.